Hi, welcome back to the channel. So in this video we're going to look at the last question in this worksheet, which is question 6. Okay, so we have looked at all these questions that we have right here, from question 1 all the way to question 6 that we are doing right now. So check out the link of the playlist in the description of this video. Okay, so question 6 says derive Simpson's rule with error term by using this expression that we are given right here. Okay, so one thing that we are particularly finding out, or what we are finding, is a naught, a sub 1, a sub 2, as well as what, as well as k, because that's basically what is missing in this one to make it to make it to make it Simpson's rule. So let's see how we can work this out. So firstly, if we were to look at us finding the value of the values of a naught, a sub 1, and a sub 2. So looking at another information that we are given is that we are said the question is saying find a naught, a sub 1, a sub 2 from the fact that Simpson's rule is exact for f of x equals to x to the power n when n is equals to 1, 2, and 3. Okay, so one thing we know is that our f of x is equals to x to the power n, and we are moving from n is equals to 1, n is equals to 2, and n is equals to 3. Okay, and the expression that we are given, okay, the expression that we are given is from x naught to x to the power 2 of f of x dx is equals to a naught by f of x naught plus a sub 1 f of x sub 1 plus a sub 2 f of x sub 2, then here we have plus k by f to the k of c, like that. Okay, so one thing we are going to be doing is that we are going to be computing this to that to find the value of what, the value of the values of a naught, a sub 1, as well as a sub 2. So it's just this portion equated to this part. We'll leave out the expression for k for now, because we'll have to find that a bit later. Okay, so let's see how this works out. So before I go any further, one thing you need to remember is that your x naught is equals to a. Okay, then your x1 is equals to a plus h. Then your x sub 2 is equals to b. Okay, and you need to know, or to say, or remember to say, h is simply equals to b minus a over 2. Meaning, if I want here, instead of b, I want to write b in terms of h and a. Okay, because I have a here, I have a and h here. I want to have something uniform. Let me just do with two variables. So this is going to be like your b will be equals to a plus 2h, and that's exactly what I'm going to use here. Okay, so we say a plus 2h. So from there, this is what our b, by the way, is. Like we say, b is equals to a plus 2h. From there, let's now begin doing the computation. So first of all, let me compute for this one here. What I mean by computing is that we have this function here, and remember, we are starting from n is equals to 1. We go to n is equals to 2, n is equals to 3. Okay, so it's like you're going to come up with 3 sets of equations. So if you say let me start with n is equals to 1. So what this means is that for this part, use this one here, okay, where there's n, plug in 1. Okay, so that's going to be like the integral from x naught to x sub 2 of x, because x to the power n, our n is a 1, it's just that there, so that will be dx. This will be equals to x to the power 2 divided by 2, evaluate from x naught to x sub 2. This is just going to end up giving you x sub 2 squared minus x naught squared, okay, divide by 2. What is your x sub 2? X sub 2 is simply a plus 2h squared minus, what is your x naught? Your x naught is a squared. I'm just getting from these and substituting here and here. So this is divide by 2. What can you do? You can actually break this down. That's going to be like a squared plus 4ah this is h by the way, okay, then plus 4h squared, this is minus a squared, divide by 2, this and that goes, so you have a 4 here and you have a 4 here, you have a 2 on the denominator, so that's just going to be 2ah plus 2h squared. Okay, that's what we end up with. Okay, so that is for this part. So let me choose to write it down here. I'm going to need it again. So 2a h plus 2h squared. Okay, we are still under n is equals to 1. So let's get to this. We just approximated this part. Let's approximate, or we just evaluated rather. We evaluated for this part. Let's approximate for this one now. Okay, so what we do there is that the way I would want you to see it, like for you to make this easier, is that see it this way. It's more like you are saying a naught by f of x naught. Remember, f of x is x to the power n. So do this. This is going to be like x naught to the power n plus a sub 1 x sub 1 to the power n plus a sub 2 x sub 2 to the power n. Okay, and in this case, since we are dealing with n is equals to 1, just substitute 1, 1, and 1 here. Why am I trying to generalize it like this? It's simply because we are still going as far as n is equals to 3. So here, this is going to be a naught by x naught to the power 1, which is just x naught, and our x naught is what? Is a from this. Okay, then we say plus a sub 1. Okay, x sub 1 is this right here, a plus h, so that's a plus h plus a sub 2. What is a sub 2? A sub 2 is a plus 2h. Expand this, you have a naught, okay, a naught by a plus a sub 1 by a plus a sub 1 times h plus a sub 2 times a plus 2 a sub 2 times h. Okay, one thing you observe here is that you have your a here, you have an a here, and you have an a here. Basically I can say it's a open bracket a naught plus a sub 1 plus a sub 2, like that. Okay, so what else do we have? One thing you observe is that for this one and this one, h is common, so I'm just going to say h open bracket a sub 1 plus 2 a sub 2, like that. Is it? Yeah, that's the way it is. So it simply means this part here together with the one that I've erased is when we evaluated for this one, we ended up with something like 2ah plus 2h squared. Now we equate it to the approximation, which we have found as a. Then what do we have here? We have a naught plus a sub 1 plus a sub 2 plus h open bracket a sub 1 plus 2a sub 2. So this right here is equation 1. Okay, that's equation 1 right there. Okay, so let's go ahead and evaluate and like try to determine this when n is equals to, and when n is equals to 2. It's just repeat the same process. So in this case here, we are going to evaluate the integral for x squared. Why x squared? Because you plug in 2 here. Okay, so this is going as far as x sub 2, then x naught dx. If you perform that integral there, that's going to be x to the power 3 divided by 3. Okay, so this is from x naught to x sub 2. Okay, so this is going to be x sub 2 to the power 3 minus x naught to the power 3 divided by 3. Substitute. While there's x sub 2, you plug in a plus 2h to the power 3 minus, where there's x naught, plug in a to the power 3 divided by 2. Okay, once again, just expand this part. Then of course you're going to subtract 2, you're going to subtract a to the power 3. What you're going to end up with, okay, what you're going to end up with is what you're going to end up with is something like it's going to be a naught. Is it going to be a naught? Let me see. Yeah, it's just going to be a. It's just going to be 2ah. Okay, that's going to be 2a squared h. Okay, plus 4a h squared plus 8 over 3 h to the power 3. That is after you expand this one. What I mean is that for this one here, just more like write it as, if you expand the first two, because this is basically more like a plus 2h squared by a plus 2h, like this. Okay, if you expand for the first time, like if you say a plus 2h to the power 2, this is just going to be a squared plus 4ah plus 4h squared. Then again you multiply it by what? A plus 2h, like this. Then you're going to end up with that, of course remembering that you have a 2 on the denominator. Okay, so I'm just going to write this right here. So this is 2a squared h plus 4a h squared plus 8 over 3 h to the power 3 is equals to, we're going to have to find the other part. So that is the evaluation, okay, of the actual function itself. Then let's look at the approximation now. So for the approximation, remember I said it's just basically you having, it's like you have x naught to the power n here you have x sub 1 to the power n, here you have x sub 2 to the power n, meaning now just substitute 2 in there. So that's going to be like a naught, then you're going to have x squared plus, x naught squared, then you have a sub 1 x sub 1 squared plus a sub 2 x sub 2 squared. So this, okay, so for this here we're just going to substitute again. You're going to say a naught, your x naught is a, okay, that's going to be a squared there, like that. Okay, plus you're going to say a sub 1. What is your x sub 1? X sub 1 is a plus h squared plus, so here you're going to have a sub 2, x sub 2 is a plus 2h, then you square it. So this again, if you expand this, okay, if you expand this, you're going to find yourself writing this as a naught, okay, you're going to find yourself writing this as a naught, or rather not really a naught, let me use it's going to be a outside but a squared instead. Then in the brackets you're going to have a naught plus a sub 1 plus a sub 2, like this, plus 2ah, let me try to create some space, we say plus 2ah open bracket a sub 1 plus 2 a sub 2, then we say plus h squared, then you have a sub 1 plus 4a sub 2, and this right here is my equation 2. Okay, that's our equation 2. So I believe you have now noticed the pattern that we are using. I'm now going to go to n is equals to 3. This is for n is equals to 1, n is equals to 2. Now we're going to go to n is equals to 3. So if you use the same steps that I used, then you go to n is equals to 3. You evaluate the integral here, then you also perform the approximation here. You're going to get the third equation that I can write as, and it's a pretty long equation. It's going to be this way. It's going to be, let's see if I can use this space down here. It's going to be 2a to the power 3 by h plus 6a to the power 3 by h squared plus 8a h to the power 3 plus 4h to the power 4 is equals to. So this is as a result of you evaluating the integral here. What I mean by evaluating the integral is that you have from x naught to x to the power 2 of x to the power 3 dx, meaning you are saying is x to the power 4 divided by 4. After that, you evaluate from x naught to x to the power 2, meaning this is going to be more like a b to the power 4. Okay, it's b to the power 4 minus a to the power 4 divided by 2, sorry, divide by 4 rather, by 4, and you know to say your b is equals to a plus 2 h to the power 4 minus a to the power 4 divided by 4. When you expand this, you're going to end up with what I've written right here. So I'll leave that part for you. So this, if now you perform the approximation, it simply means where you have n here, plug in 3. Okay, plug in 3 there. So what you're going to end up with is something like a naught. Okay, you're going to have a naught open bracket. Is it a naught? No, it's just a. You're going to have a here, a to the power 3. If you observe, it's like a pattern. You have a1 here, you have 2, you have a 3 there, like that. So this one now, in the brackets, you have a naught plus a sub 1 plus a sub 2. Okay, then you say plus. You're going to have 3a squared h in the brackets. You're going to have a sub 1 plus 2a sub 2. Then you say plus. This is going to be 3ah squared. Then you have a sub 1 plus 4a sub 2. Then the last part is h to the power 3. Then you have a sub 1 plus 8a sub 2. So this right here is equation 3. Okay, so now how do we get to simplify these 3 equations that you have? So for these 3 equations that you have, one thing that you have to keep in mind is that to simplify, okay, to simplify, in simple terms, to simplify, I'm going to allow my a to be equals to 0. Why am I doing this? I'm doing this because the rule, the Simpson's rule, must hold for any interval. Okay, if you look at this here, your x0 and your x2 can be anything, so this must hold for any interval, in short. Okay, so there's no harm in me assuming that my a is equals to 0. Okay, you can assume any number, but it's more easier when you assume a is equals to 0. So if you assume a is equals to 0 from equation 1, if you plug in 0 here, this will be 0, so meaning you're just going to have 2h to the power 2. Let me try to use black or blue. So you're going to have 2h to the power 2, because that gives you a 0, is equals to this here. If you plug in 0, to be a 0, so you just have the other side. So that's going to be h a sub 1. So you have a sub 1 plus 2a sub 2, and allow me to name this as equation 1.1 since it's coming from equation 1. Go to equation 2, plug in 0 here to be 0, 0 here to be 0, so you have like 8 over 3 by h to the power 3. This will be equals to, plug in 0 here, plug in 0 here, then we just remain with that, which is h. Then in the brackets you have, that's actually h to the power 2, you have a sub 1 plus 4a sub 2. Allow me to name this as equation 2.2. The last one, if you plug in 0, 0, 0, you just have what? 4h to the power 4 is equals to, this will be 0, that will be 0, this will be 0, so you just have what? h to the power 3, open bracket, a sub 1 plus 8a sub 2. Okay, once again, this is equation 3.3. So we have basically simplified all these. Okay, we don't need them anymore. So we can simplify these equations that we have come up with a little further as well. It's like you can, for the first one, divide both sides by h. That's going to be 2h is equals to just a1 plus 2a2. Then the second one, you're going to have 8 over 3 h squared is equals to h open bracket a1 plus 4a2, like that. Then the last one, you're going to have 4h. No. For the previous one, I've actually made a mistake. This is just going to be equals to since like you have a 2 and you have a 3 here, the one with a 2 is going to go through, just remain with h here is equals to a1 plus 4a2. Similar to this one, you're just going to have 4h is equals to a1 plus 8a2. So what you do here is that these are our three equations. There's 1.1, then there's 2.2, and there's 3.3. So for these equations, you can subtract one from the other, like repeatedly. So if you want, you can say 3.3 minus 2.2, or you can say, let me pick randomly, let me say 1.1 minus 3.3, or I say 2.2 minus 1.1. Let's see what you're going to get. So 3.3 minus 2.2. So here you're going to say it's like 4h minus 8 over 3h, which will be equals to this one minus this one is a 0, right? a1 by a1 minus a1 is a 0. Then 8a sub 2 minus 4a sub 2, that's just going to be 4a sub 2, like that. Then here you can make this a single fraction, so that's going to be like 12h minus 8h is equals to, you have a 3 on the denominator, by this one that's going to be 12a sub 2. So you subtract here, that's going to be 12 by 8 is a 4. You say 4h is equals to 12a sub 2. So your a sub 2 will be equals to 4 divided by 12. That's going to be 1 over 3. So it's going to be h over 3. Similarly, if I will choose 1 minus 3.3, so if I subtract this one minus this one, that's going to be negative 2h is equals to this one minus this one is a 0, obviously. Then this one minus this one, what is it going to be? It's minus 6a sub 2. Divide both sides by 6, and the negative of course goes. You have a sub 2 is equals to 2 divided by 6, which is a 1 over 3. You have h over 3, which is the same as this one. In a similar way, that's the same thing you're going to get here. So one thing we will find that our a sub 2 is equals to h over 3, like that. Okay, so that's what we get as our a sub 2, meaning you remain with a sub 1 and a sub a naught or a sub 0. So but from this or any of these we can find our a sub 1. So you can just say 2h is equals to a sub 1 we don't know plus a sub 2 we know, and that's going to be h over 3. So it's like 2h over 3 when I use this equation, the first one here. Okay, so having done that, our a sub 1 will be equals to 2h minus 2h over 3, like that. So a sub 1 will be equals to, that would be 6 minus 2h, sorry, 6h. You have 6h minus 2h divided by 3, that would be equals to 4h over 3. You can try in the others, it's still going to give you the same. A sub 1, we have found that is equals to 4h over 3. So now the only thing that is remaining is for us to find the value of x naught. So to find the value of x naught, we have to do some other evaluation. So remember, we have only done evaluation from n is equals to 1 to n is equals to 3. So for us to come up with x naught, we need to evaluate at n is equals to 0. Okay, so it simply means we have to evaluate the integral, like from x sub 0 to x sub 2. Here you just plug in 0, meaning it to be 1. Okay, so just put dx here to be equals to x evaluated from 0 to, from x sub 0 to x sub 2. That will be equals to x sub 2 minus x naught. Our x sub 2 is what? Is a plus 2h minus our x naught is a, so this is just basically equals to 2h. That is for this part here. We have what? We have 2h on our left hand side. Let's look at our right hand side. So for our right hand side, if you plug in 0 here, 0 here, 0 there, those are just going to be ones. So it simply means you're saying your 2h is equals to a naught by 1, which is a naught, a sub 1 by 1, which is a sub 1 plus a sub 2, like that. So this is going to be 2h is equals to your a naught you don't know. Your a sub 1 you found that is h over what is our a sub 1? Our a sub 1 I found 4h over 3 plus a sub 2, which is h over that. So if you make a naught the subject to the formula, you're going to end up with a naught being equals to h over 3. So our a naught is equals to h over 3. So these are basically the values or the expressions for a naught, as well as a sub 1 and a sub 2 that we are looking for. So it's basically just a matter of substituting them in here. But before we do that, we need to find the value of k. Okay, so to find the value of k is also pretty straightforward. So in a similar manner, if you look at question part more like part 2 of question 6, which is asking us to find the value of k by applying the integration formula f of x equals to x to the power 4. So we are given f of x is equals to x to the power 4, meaning our n is equals to 4. Okay, so if our n is equals to 4, basically the first thing that we do is to evaluate the integral from x naught to x sub 2 of x to the power 4 dx. This is going to be equals to 1 over 5 outside, then you have x to the power 5 evaluated from x naught to x sub 2. So this is going to be equals to 1 over 5, so you have x sub 2 to the power 5 minus x naught to the power 5. Okay, we know what our x sub 2 is. This can be written as a plus 2h to the power 5 minus a naught is a, so a to the power 5. So if you do your expansion here, okay, if you do your expansion, you're going to end up with something like 2a to the power 4 by h plus 8a to the power 3 by h to the power 2 plus 16a to the power 2 by h to the power 3 plus 16a times h to the power 4 plus 32 h to the power 5 divided by 5. So what am I really trying to do here? So what I've gotten here is by me evaluating the integral. Okay, so now let me look at the approximation. Here's what I mean. Firstly, I used this one here considering this one. Now I want to look at the approximation, which is that one. Okay, so for the approximation, remember to generalize it, I earlier said you can write it as a naught by x naught to the power n plus a sub 1 by x sub 1 to the power n plus a sub 2 by x sub 2 to the power n. In this case, our n is a 4. Okay, so you're basically saying a naught by x naught to the power 4, but x naught is a. Okay, this one here, x naught is a, and you're raising to the power 4, so that's just going to be a to the power 4 plus, you're going to say a sub 1 by x sub 1 is a plus h, you raise it to the power 4 plus a sub 2. What is your x sub 2? X sub 2 is a plus 2h to the power 4. So once again, you're going to expand this part as well as that part. But before you do that, you might want to consider the fact that you already know what your a naught is. Remember, we said our a naught, we found h over 3, then a sub 1 we found 4h over 3, then a sub 2 we found h over 3. So basically this is going to be like where there's a naught here, you plug in h over 3 a to the power 4 plus a sub 1 is 4h over over 3 multiplied by a plus h to the power 4 plus a sub 2 is h over 3. Then you have a plus 2h to the power 4. So this one here, expand it. If you expand it, you're going to end up with something that is something like this. It's going to be 2a to the power 4 times h plus 8a to the power 3 times h squared plus 16a squared h to the power 3 plus 16a h to the power 4 plus it will be 20 h to the power 5 divided by 3. They are like that. Okay, so this is extremely interesting in the sense that, remember, an error, your error is simply equals to your exact value minus what? The approximation. In a similar manner, if you look at our expression, which is this one right here, this gives us our error, k times f to the k of c. Okay, so it simply means you're saying k times f to the k of what? Of c is equals to, what is our exact value? In this case, we are looking at it in terms of an expression minus this approximation expression. So this one minus this one, that would be 0, right? 0 there. Then this one minus this one, you also get a what? You also get a 0. This one minus this one, you end up with a what? 0. This one minus this one, you also end up with a what? With a 0. Unless for the last part we have like 32 over 5 by h to the power 5 minus 20 by h to the power 5 divided by 3. Common denominator is 15. Okay, so 5 into 15 is 3. 3 by 32 is 96 h to the power 5 minus 3 into 15 is a 5. 5 by 20 is 100. Then by h to the power 5, this is going to be equals to minus 4 h to the power 5 divided by 15. That's what we get as our k by f of k to the c. But remember, we are looking for the value of k. That's what you're looking for. So k by f to the k of c is basically equals to minus 4 h to the power 5 divided by 15. So let's go ahead and see how we can come up with the value of k. So to come up with the value of k, we are going to differentiate this function until we reach a constant, or rather, we're looking at the fourth derivative. Okay, we're looking at the fourth derivative. So what this is going to be is that, since you already have your f of x, the first derivative is going to be equals to what? It's going to be equals to 4x to the power 3. The second derivative to be equals to 12x to the power 2. The third derivative, it will be equals to 24x. Then the fourth is just going to be equals to 24, like that. So we are basically saying k by 24 is equals to minus 4 by h to the power 5 divided by 15. Okay, so k will be equals to minus 4 by h to the power 5 divided by 15 times 24. Okay, 4 into 4 is a 1, 4 into 24 is a 6, so that would be equals to minus h to the power 5 divided by 6 by 15 is 90. Okay, so k is simply equals to minus h to the power 5 over 90. We have everything that we need. We have the value of a naught, value of a sub 1, value of a sub 2, as well as the value of k. So we can now actually write our answer, or our expression. So initially this was more like it was written as the integral from x naught to x sub 2 of f of x dx. It was equals to a naught, but where there's a naught, we are going to plug in h over 3, then f of x naught plus a sub 1, which is 4h over 3 by f of x sub 1 plus the last one, which is a sub 2, which is h over 3 f of x sub 2. Then here we had plus k, but to be minus h to the power 5 divide by 90, then f to the fourth of, in this case, let me just say x, like that. So you can actually just factor h over 3 out. Then you have f of x naught plus 4 f of x1 plus f of x2, like that, minus h to the power 5 over 90 f to the fourth of x, like that. And this is our expression for Simpson's rule. And this is basically how we answer this question. Thank you very much for watching.